Hello and welcome to the second video about wave function collapse. So in this video we're going to start out building this dungeon level generator for a game here in Unreal. So of course everything you see here can also be done in Unity as well. So in this case we just used Unreal for demonstration. So in here I just have a little level generated with the wave function collapse nodes. So everything you see here is then being procedurally placed for you, and then we can just have some variations if you want to. And of course we can also play this, so automatically the navigation is being calculated here in Unreal, and then we have some enemies coming for you. So we can easily now generate multiple levels once this is set up. So now let's jump into Houdini and start building the basics for this. Then in Houdini let's create a new geometry node, and in here we're going to use the wave function collapse node. So I want a grid, and I also want the main solver. So, and I also need two of these. So one for the total size of my output, and one here that will then hold information about the pattern I want to use. So let's first plug in my pattern, and therefore I'm going to use a texture that I've built. So I'm going to click from texture and load in my basic texture. So in here I took this very small texture where I have a small room and a bigger room. And then I also have some dots on the side so the rooms can be connected. So we plug the pattern in here and then the main pattern over here. And now we have new patterns being generated. So of course we're gonna probably tweak some of these settings. So let's try and using the first setting, so find wrapping input. That already does something better. Maybe let's lower this to 2. So now I have this as a result. We can also keep changing the image if you're not happy. So in this case I might switch to this one. Let's see if that gives some better results. So I think that's a bit better for what I'm looking for. So you're going to have to play around with some of these inputs and see what works best for you. So in this case I think this is more in the direction I'm looking for. And what I'm also going to do here after this node is I'm going to place down a transform node. And I'm going to scale this by 5. And the reason why I scale this by 5 is just for when I open this in Game Engine, it's sort of like more the fitting scale compared to my player and so on. So this is the base setup here that I'm going to use. Now I mentioned before that we can actually also use the Wang decoder and samples, so let's do this here as well. And let's use the samples. And I'm going to use the copy to point and filter on that name attribute. And as you can see, it already gives me a decent result. So I'm going to keep this actually more on the side. This is not going to be in my system, but this is to visualize what's going on, because otherwise I'm just looking at a bunch of points, and in here I just quickly visualize what's going on. So from here, let's just put a frame around this. So this is sort of like my basic input, my basic pattern. And I want to actually do a second pattern, and this is then for my lava. So in my game I have a part that is covered in lava and a part that is just normal walls. So for example here we can generate a piece that, for example, all these parts are in lava and these connections are then bridges. So I'm going to select this and copy paste it, and let's make some changes to it because it's going to be a different result. So first of all, let's go here with the image and change the texture. So I'm going to use something like this with some more bigger shapes. So in here I'm going to take half of the size for my original pattern. So let's go to my original pattern and right click on it and copy this scale. So copy parameter and paste a reference over here. So paste relative reference. Now do this as well then for columns. So right click, copy parameter, and then paste this over here. Now I'm going to divide this by 2 because I want it to be smaller. And the main reason I make it smaller is because I want the lava to be in big chunks divided, not in smaller chunks. So I'm going to make sure that my grid right now has these bigger chunks. So let's play around with some of these settings here. And I think I'm more happy with these settings. So when I change the seed, we can see that we always have like these bigger chunks going on instead of having like small parts. So I'm gonna use this information. Then in here in the scale, instead of 5, I'm gonna have to double this because we took the half in here. So I'm gonna change that. And now I want to transfer the information from this network into this network. And the way I'm gonna do that is I'm just gonna create a grid, copy this grid on my current points, so copy to point. So I have this result now, and scale the grid, of course, to what it should be. So 1. And now from here, we have some values. If I would quickly go here, we have our value name that is either 000 or 111. So this is going to decide when there is going to be lava or not. So I want to rename attribute. And let's just only keep 1. And I want to change the name attribute, and I'm going to give it a new name called lava layout. And now what I'm going to do is using the transfer to then transfer the information from the lava layout to my main pattern. So in here, I'm going to make sure I'm going to use the lava layout. So if I would go to my attributes, I would now have a new attribute for this lava layout. And let's also quickly test this, and I'm just going to blast away based on this. So add lava layout. So if the lava layout is equal to 1 and looking to the points, then this piece is being deleted. So you can see that is that piece. So that's pretty close in what I was looking for. So this piece, for example, can then be the lava piece, or you can use the other piece. You can change that later. So the main idea is that we just have this information here as well. What I also want to do here is add a border around my level. So right now I have a level. I just viewed it over here, but I would like to have a big border around the level. You can see that by default the Wang nodes is already doing a good job of like closing the system here, but I want to use this big block over here and to continue it here so the border is closed. So what I'm going to do here is I'm going to ask the bounds, and from this I'm going to tweak in here the padding size. So let's set this to 2 and 2. Then I want to use the split by normal, primitive normal, and set this to Y and invert selection. So only have the size around them. Then I want to use a thicken node, so left thicken node, and then give this here a thickness, so maybe 20 in both directions. I think 20 is not enough, maybe 100. That seems better. And now I'm going to use a group node. And in the group node, I want to use this as my second input, which is the bounding input. And give this a name called border. This needs to be of a point group. And with this point group, we're then going to save here bounding box and use the bounding box object, which means using this second input. And you can see that we have now procedurally selected this bound. So all these dots are now being selected. Now from here, what I'm going to do is I'm going to use a color node, and everything that is in the border can then be of a specific color. So in this case, I'm coloring them white. So you can see the before. So here before we had some of these dots over here, which are these drawing nodes, which are these models. And now they have this border now. Now from here, I'm going to group this as well. So this was to make a border. And now I can use a Wang node. And this is then used to calculate my tiles. So let's just move this over here. And you can see that now I have a border for my level. Also make sure that the rows and columns are always linked to your original size. So that's also very important to do. And also the rank tile works on color. So keep that in mind, that if you don't do this color node, you see what changes to this tile. Now the next step I want to do is I want to delete the pieces that are not connected to each other. So if I want to play this game, I can walk around in here, I can walk, but in here in these pieces, they are not really doing anything for the level. They are just there, but the player would not be able to reach them. So you can either make a system to add bridges, or you can also make a system to then delete these smaller chunks that are there. So, but in this case, what I will be doing is let's use a copy to points and copy a grid on these points. So from the Wang decoder, let's plug that in over here. Also, again, make sure you set the scale here to 1. And now we have this grid. Now in this grid, we also have still our lava layout and our name attributes. So I can use these attributes in a blast node. And in here, I can then, for example, say add name. If it's, for example, equal to 0, delete them. Also make sure you are in point groups. And now it's deleting all the pieces that are these chunks over here. So it's deleting piece number 0, which were just like empty space. Then from here, we can then use the extract silhouette. So use this node. And we have to set this to the y-axis. And now it's getting the silhouette from these pieces. Now from here, we can then also use delete small parts. And in this node, we have an option to only extract a large piece. And this is what I'm actually looking for, because the largest piece will be the most playable area. So I'm going to use the ticker node here again. And again, set this to, for example, 50. 50 was maybe too much. So in this case, 10. And use this with a group. Just like before, we're going to use the bounding option. So make sure this is in the second input. Set this to points. And this is, for example, a name called big area. And then we use the bounding region again. Set this to bounding object, so it uses the input. And now all these points that are selected are my main playable area. Now from here, I can just, for example, place down a wrangle node. And we can use the group big area that we just made and invert them by an exclamation mark. And I can say here, add name group is now 0. So basically what I'm saying here, that if my point is not in the big area group, it can then be changed to name 0, which will mean this empty space. So if I would change this over here, we have now filtered out these parts as well with this wrangle. So this is then over here another system finished. So let's wrap that up in a frame as well. So this is to extract the largest playable area. Then we have almost everything set up to already do a quick test in Game Engine. So from here, our basic layout, our basic setup is actually almost done. So I have everything ready to use in Game Engine. Only thing now that I want to do is to start using the instancing. What I will do first is using a blast node. And with this blast node, I'm actually going to delete all the empty spaces. So again, here at name, if it's equal to 0, just delete them. So set this to points. All these empty spaces are now being deleted. So this is then the result without empty spaces. Now further from here, we can then do a split node and split between if it's in lava space or if it's just on the normal space. So we're gonna use the lava layout. So at lava layout, if it's equal to the 0, 0, 0, then want to split them up. So make sure again, set this to point, and now we have this result. Now from here, we're gonna set up Unreal instances. So what I normally would do is create an attribute and plug this in over here, and then set here, type in Unreal instance, and make sure it's set to a string. And then in here, I would type the path to the model to use. But in this case, since we are using the wank tiles, we are having 47 different possibilities. So that means that we either have to use this 47 times this node, or we can do something a little bit different. We can use the value replace. So over here, I'm gonna plug in the wank tile sample in the value replace node, and then press initialize values. So you might get an error, and the reason why is because name is not available. So that means that name is actually stored in primitive. So I'm gonna have to do a promotion. So promote attribute, and from primitive to points. So name has to be changed to points. And now when I press initialize, I will have these 47 different possibilities of tile sets, as you can see over here. So these are all the possibilities you need to set up. So let's plug this in over here, and we need to set this up. Also here, we also need to rename the attribute because we are working with Unreal. So let's change this to Unreal instance. If you're working with Unity, you're gonna have to, of course, change this to Unity instancing. And then we can also going to use the default value. So now let's also use the default value. So if I would type in here a path and then press initialize, we have automatically changed everything to the value called path. You can also see this if you open the attribute here. We have changed the Unreal instance to path. Now most of my points here will actually be a floor. So what I can do is I can give in my path to the floor, and then automatically everything has been assigned to floor, and then I can manually change some of these paths to what they should be. So going into Unreal, I have here my models. So they are all in blueprints now because they are sort of like my prefabs and easy to change. And I'm going to use my floor model and copy this everywhere now. So in here, main floor, I'm going to right click, copy reference, and use this in Houdini. So I'm going to copy this reference here and press initialize, and everywhere I have now set up this value. Now also here again, I want to mention that these numbers are not random. They are coming from the blob tile set, which is used in the Wang nodes, and each number has then its piece. So if you would double check, for example, number 7, then I would know that number 7 is here, this piece here. So each number has its very specific direction. So it's very useful to have this information. So we're gonna have to set up these to the right blueprint or models. And this might take some time. So I might skip this part. So now it's set up. I have also not support for all pieces, for most of them, but that's why I filled in this default value that if there would be a piece missing, just use my floor model. So these can then be merged together. And one more thing I want to do here is if I would check my output is I don't have any normal. And most of the time that's quite important to set up a normal. So let's create an attribute here and just call it n from normal. And a normal has 3 values and I'm gonna leave it like 0, 0, 0. Now we are ready to make a digital asset from this. So I'm gonna select the system that I just made. And either we can go up here, create digital asset from selection and give this a proper name. And now we have this menu popping up as well. And let's also go to the parameter menu and let's pick out a few parameters to use. So in here, I want to go to where I have my main size and I want to expose the rows and the columns of the main size of my patterns. Also, most of the best results you will get out of a square shape. Then also interesting here is the seed, and I'm gonna call this seed for the playable area, so player layout. Then I'm gonna go over here to where I have my lava, and I'm gonna use this seed as well, and then seed for the lava. So I'm gonna press apply, and this will pop up green. It means it's linked. And these values, these rows and columns, I'm gonna make sure to link them to the Wang tile I used here, so they are consistently used. So rows and here the columns. So these are all also linked, so that stays consistent. Now we can expose more values if we want to, but with this we can already change the size, and also we have some seed values. What you can also expose is, for example, the image you're using. So you can just drag and drop this also here, and you can fill in a file in Unreal itself, so you can quickly change this. So you can quickly change that as well. Also, what I want to do here before testing in Unreal is using a output. So this is just to make sure that I'm always outputting this result. So let's then save this and test this in Unreal. So here in Unreal, let's grab my H2A, drag drop it in the scene, and after a moment it will then load in my level. And as you can see, it's working. So I have my main layout, and where I have no walls will be then the lava, and where I have my walls, it will continue building walls. There was one small thing I needed to do to make this work. In Houdini over here, I had to use an attribute delete and delete the transform attribute because this was conflicting with my instancing. So in here, let's just quickly test out what I'm having now. So let's change, for example, the player seat. So, and as you can see now, I have my new layout. Also, if you have set up a navigation mesh, it will also calculate the navigation. Then we can also here play around with that lava seed. Then it will keep the player layout, but it will move some of these walls and placements. So that means that my lava will be over here and not over the other levels. So that could be really cool as well. So from here we can just make it bigger, keep changing the seed. We can also start making the grid bigger. So let's say I want 30 by 30. As you can see here, now I have a way more bigger level. So then in the next videos, I'm gonna make this a bit more polished. So right now I just have a basic setup with my base layout, and in the next videos I'm gonna make sure I'm finishing up the decoration and that we can play this level and then we have some decoration in this room. I hope you enjoyed it and thank you for watching.